let's start with our conclusion first, and then we'll work backwards to see how we got there. We're going to make the case that this 400-gram container of jack spites is about the right size for an OEM version of the ICE. That's 400 grams for the left front tire and the right front tire, so a total of 800 grams. Let's see how we got there. The 400-gram payload is enough to stop in many climates, to do a complete stop from 100 in the conditions that arise from the first few minutes of rain after an extended dry period. So something floats up off the road and becomes very slippery, and because it's a very thin layer, these jacks can bite through that surface back into the road and reestablish traction. So we're making a case that the OEM design would center around the minimum size of what's needed in a large segment of the climates in the U.S., or in any place for that matter. As you move north or into climates that need more capacity, that's a simple matter of adding extra hopper capacity on the top of the existing unit. Nothing else changes. It's just how much does it hold. So if there's space left in the design of the vehicle for that added capacity, it's a very simple process to just add that as needed, and does not impact the fuel economy ratings at that point. We're going to take a look at this from two different angles. One is black ice. We've got a very thin layer of water or ice sprayed on a concrete block, and the other is a microcrystalline wax, to show that it's more a matter of the thinness of the slippery surface than it is of the chemistry or anything like that. So what we're trying to get to is, if the surface is thin, the ceramic jack spites will dig right through it into the surface below and bring the coefficient up to somewhere around 0.35. Because we're in a mild climate and this condition is fairly rare, probably every 2 or 3 years, that there's no need to have a extra capacity. Just have a capacity for one event, and refill can take place at an oil change. That's 11. 9, so 0.09. We might be, of course our scale is pretty funky too. There's an 8, 8, 8, 7, 6, 7, 7. We're at about a 0.07, excuse me. So it's about a point. We'll put on 1 gram of jack bites and spread them over about 1/3 of a meter. Look even. Looks about right. Add a little bit and try it again. .34. Now we're going to run the same test as we did with the black ice, only this time we're using something called Renaissance microcrystalline wax polish. See if you can get a good look at that. There we go. 0.24, 0.24, 0.25. That's kind of where we thought we'd be. Lay out 1 gram of ceramic jacks, and we'll spread them for about 1/3 of a meter here, even though we won't use all that. We'll go right here. And let's see what we get. So we went from a 0.24, 0.25. Oh, let's see what we get. .35. We started at a higher coefficient. That's interesting. And 0.33. Well, let's do the math. We're going to start. We're designed around 100 kph, 60 some miles an hour. That works out to 27.77 meters per second. So we square the 27, we get 771.6. That comes out to the distance of 112.5 meters, 3 grams per meter. So that gives you a total payload of 337 grams. And we'll give ourselves some extra, we'll call it 400 grams. In conclusion, the ICE is lightweight, 700 to 800 grams per total vehicle payload. It's of universal interest all over the country or all over the world. It's not just for northern climates. We can see that it's dramatically effective, in some cases improving the coefficient of friction by 4 and 5 times, depending on the situation. So, thank you.